in the last couple of years, the focus has shifted to voice AI. So you have even use cases where a real-time language model translates text to one language from one language to other language while the caller talks to you. And there are certain uses where in real time you understand if the caller is spam call or not. These are not released in open source, but these are the use cases that our customers are trying to do on our platform. Many of you may know Qualcomm only as a mobile phone chipset manufacturer, but I think from the past 5 years we are trying to venture into multiple diverse domains. So today we have at least 25 plus cars powering with the Snapdragon platforms, and our cars power the IVI, that is in-vehicle infotainment, and ADAS use cases of the automobile. You also have use cases like virtual service advisor, where you can interact with a car and understand the predictive maintenance requirements in the certain car. So every car has a engine control unit and a CPU. So you have like multiple sensors. So ECU and CPU gets data from those sensors, and it can let you know what is the current health, and it will let you do predictive maintenance of your automotive. We have been venturing into PC space and aggressively from last 3 years. So you have AI powered Copilot PCs with Snapdragon chipsets powering it, which has like more than 1.5 day battery backup, not just 4 or 5 hours. And on a PC, like what is possible? It's all possible with Snapdragon platform. The QIDK platform that's there in the university is almost as capable of a Snapdragon Copilot PC. Similarly, we also have multiple business segments where we extend this to extended reality and mixed reality, and then industrial IoT, industrial automation. We also have Wi-Fi routers with Snapdragon chips, which are AI capable. The purpose of this slide is to show the spread of our use cases, not just in a handset market, but extending to a workstation or a laptop and automobile, to all the way up to mixed reality and industrial automation. So, like, why do on-device AI? Like, when we have a cloud API that we can directly call and get things with, why even do on-device AI? What is the purpose of it? So, on-device AI is very much necessary for performance and efficiency. Assume you have a robotic sorting hand, or assume you have a mixed reality glasses. I'm just quoting one of our customers, Ray-Ban Meta. So if you want to see and understand and take decisions very quickly, you cannot afford the latency of calling a cloud API every time. Sometimes you will need to take decisions very, very quickly, and you cannot afford the latency and unpredictability of a network communication. That's one part. Second part, most of the sensors you are reading data from are local to your device. So you have this camera, and I hope like everybody knows how many sensors a mobile phone has, right? A mobile phone has a camera, audio sensors, gyroscope, magnetometer, accelerometer, many more sensors. So all these are sitting natively on your phone, and it's very quick and efficient to take any calls on the device itself. Of course, there are use cases where you can accelerate like AI use case, complex AI use cases on cloud. So moving on, later in this presentation, you will see our focus of offering a edge, cloud, and a hybrid solution entirely on Snapdragon platforms. So personalization, user-specific personalization, privacy and security, and reliability are key concerns of running on-device AI. Also, there is another key concern that industry is having, which is cost of inferencing. So cost of cloud computing, calling a cloud API is not free. It does cost a few dollars for few million tokens. And as and when you start using it more, you will need to keep paying more. That's not the case with like on-device AI. So in this particular slide, we want to show how the smaller models are almost becoming compatible with the largest model. So GPT-4o, as you know, this is the model that was used in OpenAI GPT a while ago. On May 2024, it's released. Unfortunately, this is not a public model, so we don't know how many parameters it has. Whereas we have distilled models in February 2005 from another region, for DeepSeek R1 District 1 7 billion parameter. For those who are not aware, GPQA Diamond is a data set which is supposed to be solved only by PhD level humans. So it has like many tough questions. If you give it to a certain PhD in a domain in a domain expert in a certain domain, he will be able to solve 60 to 70% of the questions without any external help. That's the idea. If you give it to a standard individual and let him browse the web for say 30 to 35 minutes, they are able to get approximately 40 to 50% accuracy only, not more than 50%. So this is the standard of quality of this particular data set. And if you see the level of performance that GPT-4o has achieved in May 2024, in less than a year, maybe like 1/10 or even 1/100th smaller model is able to achieve similar performance. So this is the fundamental motivation for us to advertise on-device AI. Models are evolving very, very quickly, and the knowledge per number of billion parameters is exponentially increasing. So you cannot assume that a 7 billion parameter model doesn't know much, and only a 400 billion parameter model has very good knowledge. So the amount of knowledge model developers are able to pack in a billion parameter is exponentially increasing a lot. So this sort of motivates every user to shift some of the AI workloads, if not all, to edge devices so that they can realistically and power efficiently serve the AI inference. Okay, moving on. So this is another slide where we tried to show the progression that we showed a while ago. So if you see the previous models like Llama 2 chart model, 7 billion parameter model, they were like very inferior compared to GPT 3.5 Turbo, which is around 175 billion parameter model. However, like almost like 1.5 years later, from July to October 2024, we have few models like Pixel and Mistral, where they are able to get very close to the largest model which is being used in the top-notch AI solution provider. So this is a primary motivation for Qualcomm and the industry to shift most of the AI inference workloads to edge devices. So this is not only with one data set. I think this slide is to emphasize that the previous data is not just limited to one data set. It's only like shown in the purple color. You have many more data sets for each and every use case, for math use case, like basic STEM use cases, multiple use cases. Almost everywhere, we clearly see this pattern that like recent models, which are like around 7B or even like 30 to 20 billion parameter model, are able to come very close to the largest billion parameter model. So this sort of means next comes to the cost. I think I covered model quality index and sort of emphasized how we can move to smaller models without compromising the quality of AI inference. Now I'm trying to cover the cost part of AI inference. Even if you take the cheapest part of this particular slide, which is again open based on a open source data. So this still doesn't come for free. You will still need to pay certain dollars, even though it's very small, for 1 million tokens. And this particular cost will keep on increasing if you would like to do inference very frequently. So we have few customers who gather data across multiple sensors and send it to some of these cloud API providers, and they have few concerns about huge amount of cost they are incurring. So we have like active requests from multiple customers to move at least some of them to edge inference so that they can minimize their cloud platform costs. So this particular slide sort of tries to give you the best of both worlds. So while we say that edge AI is able to meet most of the use cases, there are still very good amount of possibilities that you can do with a central cloud. So Qualcomm is probably the only company which offers end-to-end solution. We have a cloud service, we have a cloud chip, we have a edge chip, And we have like AI workloads which are distributed across hybrid and cloud. So I'll not spend much time on this because it's up to the solution architect and on how he wants to distribute the AI workloads across cloud or edge devices. I'll just move on. These are like just okay. So coming back to like the capabilities of our platforms. So I just tried to put most of our platforms in here. QIDK will sit somewhere in this bracket. So we are able to run at like around 10 plus billion parameter model comfortably on the QIDK level platform, whereas the capability of other platforms will slightly vary. We'll be able to run maybe around up to 30 billion parameters on a automobile and around say 1 billion parameter model on a Wi-Fi device, Wi-Fi router and a robotic arm. So all we are trying to say is we have appropriate software stack that lets you prepare a model once and run across multiple platforms. More on this later. So the newer request that we are serving our customers each and every year is longer context length. So we started with approximately like 1K or 2K context length. Now we went ahead all the way up to 18K, and we are also exploring 16K. Personalization of models based on deployment scenario is another key aspect, and serving multimodality, not just text input, image input. We have like now models running from our customers who can take text data, image data, and also call them. And we also have like use cases where people are running models concurrently. Gone are the days like where people can run only one model, initialize a model, run a use case, and then deinitialize a model. So our customers don't use like that. There are like many concurrent AI plus computer vision plus audio use cases which are actively using multiple models, such models. Okay. So I think here in this slide we want to emphasize that even industry is moving towards what we are talking about. It's not like Qualcomm is in this thought process in isolation, and we are moving along with the industry for this. So if you see the number of models which are larger, when we say larger, approximately 100 billion plus parameters, and smaller are less than 10 billion parameter. So in 2021 itself, like we have like a decent number of largest models and a very small number of smaller models. This particular gap has been widening very recently. And if you see by the end of 2024, we have too many small models and little largest models. So this is not just because of say GPU power or GPU richness, but this is also because of industry realizing the fact that a group of smaller models in a mixture of experts architecture or something else is able to perform as good as a largest model. So you don't need to drive a truck to office every day. You can drive a smaller vehicle. I'm just trying to draw analogy between vehicles and the model capability. You can have multiple smaller experts in multiple domains, and you can have a larger orchestrator or a layer which are bringing them in whenever needed and pruning them out whenever they are not needed. So such layer is really important for the entire industry, and this is where the future is. So what do we do on Edge AI, right? So we support every key use case that is already supported in cloud, probably with a smaller model. So we support like text creation, that is content generation, summarization. When you say content creation, there are customers who are using like video creation, audio generation, or like greeting card generation, multiple other use cases. Photo video editing is anyways, I think you know very well. So we have generative AI based plugins to do photo video editing across multiple platforms in Adobe and like in Blackmagic, many other deliverables. So productivity is to summarize emails, these kind of use cases. AI assistant is a voice plus text. We also have Visual Studio plugins to generate and review code entirely on device. And live translation is also a key use case that's supported across multiple platforms. Now that we have the power of what to do AI, what to do with AI, and also Qualcomm has an advantage in here because we are sitting very close to the sensors. So we have like various sensors. I think I'm putting around 5 sensors in here that are the key ways in which you interact with your phone or any electronic device. Normally, we interact with any electronic device in terms of voice, touch, by using the camera, which is photos or vision, and any of the sensor ecosystem. So if you understand this as our sensory ecosystem for the entire AI use cases, then comes an AI agentic orchestrator in between, and this particular agentic orchestrator will be able to swap these use cases across multiple platforms, creating a global ecosystem and seamless possibility of use cases. This particular orchestrator will have access to any of the cloud services, whether it is a public internet or whether it is your user specific calendar location or anything else from weather, news, whatever. And then finally, we will be able to derive multiple use cases. So these are the use cases where you can directly talk to a phone and get the phone talks to appropriate agents in the web and gets you what you want. So this is where you can realize your entire task with UI, that is with AI. That's the reason we are calling AI is the new UI. So the level of interaction with a edge device will be very limited in the future, and AI does most of the things for you in the background based on your preference and gets you what you want. So as I said a while ago, like we have our presence to scale edge platforms across multiple business units, not just mobile, but across multiple business units. So how do we like then what do we suggest? So Qualcomm has a fundamental philosophy that we should train models on cloud platform, because we don't support training on our platform at. We support fine tuning of few models on some of our latest platforms, but model training is not our USP. So if you take a model, training a model is more probably around 20 to 30% of its lifetime. Most of the model lifetime, around 70 to 80% of it, is spent on inferencing and fine tuning, not just on training. You train a model only once, but you deploy an inference and keep on doing inference with the same model. And whenever the model doesn't meet the accuracy, or you have the data around the model changing, you will collect the latest data and fine tune the model based on the deployment scenario. So this is possible on latest Qualcomm platforms. So that's the reason we advertise train on cloud and run on Qualcomm platform. So Qualcomm has built the fundamental technologies to derive the entire edge ecosystem, right from hardware till software and tools levels. So in the next few slides, we will show our hardware innovation and what are our software stack that enables end-to-end AI running on edge and cloud and in hybrid mode, and how can you use these platforms is going to be covered by my colleague. The platforms that we offer and the university has is a heterogeneous system on chip. So you don't unless some of our competitors, our AI workhorse is not GPU. Our AI workhorse is NPU, neural processing unit. NPU is a form of compute DSP which can run like 128-bit instructions in a cycle, and with very good power efficiency. The power budget of an NPU is almost 1/3 of a normal CPU. That's how quick and how efficient NPU runs AI workloads compared to our GPUs and CPUs. So our NPUs are also capable of running the models in quantized precision without much accuracy loss. So here I'm trying to show a demo which is done in collaboration with one of our partners. So on latest Qualcomm platforms, you can run the models in not just intake precision, but on infer precision with very little quantization accuracy loss. So in this slide, I'm trying to show the capability of our NPUs. So I'm trying to showing a stable diffusion 1.5 model, generating output for multiple prompts in sequence And please see the difference between, say, our hexagon processor, GPU, and CPU. And all this happens at approximately 1/3 power budget of the CPU. So this is the brief overview of our software stack. So on top of open source operating systems, Qualcomm has built a SDK stack, and like that takes the AI frameworks that supports all AI frameworks and runtimes. You can bring in any model from any popular AI framework and use our tool chain to convert the model, to prepare the model on our platform. And once it is prepared, you can seamlessly run it across multiple platforms. So the next slide shows two possible workflows. So we have a workflow that is dedicated to some of our customers. This workflow is a bit involved and gets you the best performance. For third party audience like developers or students, we encourage them to use delegate path, where they can directly run any models on the platform without much development overhead. I'll skip these and directly move on to next things. So we also have something like Qualcomm AI Hub. Qualcomm AI Hub is a platform where we host all our pre-optimized AI models, and we also offer something like BYOM. So we have something like bring your own model in here. You can also bring your own data and customize the model on a cloud infrastructure like AWS. So there are approximately 200 plus models already available, and most of them will be able to run on the QIDK platform that the university currently has. Along with it, you can also bring in your model and upload it to Qualcomm AI Hub and export the model for certain platform. Also, you can bring in your data and customize the model, then download the directly deployable model on a Qualcomm platform. So this is the end-to-end workflow, and AI has very clean documentation to achieve these things. So recently, Qualcomm had acquired something like Edge Impulse. Let me go back. Edge Impulse is our recent acquisition. So we are sort of merged with Edge Impulse now. Edge Impulse solves the problem of deployable AI models slightly differently. Their platform is very easy to use. You can use the device to gather data and build model, customize model, and prepare a deployable model. Why it is necessary? For example, if you are deploying a edge use case in an oil rig or in a product industrial automation scenario, you will not get the data for this particular domain available in open source. Also, the customers are not willing to share data openly outside. So what we can do is we can have the hardware installed in the customer premises, gather data on-prem, or gather data on device, and train or fine-tune the model with the entirely zero-code platform. It's entirely zero-code platform. You can train a model, you can optimize the model, prepare for deployment with few clicks. Whatever model developers do with PyTorch, you will be able to do with few clicks. Yeah, this is just showing what other use cases are possible in across multiple business units. So okay, I just want to sign off by explaining this particular slide. So it's up to the AI solution architect on where he wants to run the use case. However, currently on device, we are able to run most of the AI use cases with very good performance and efficiency. And while doing it, your data doesn't leave your device. So privacy and security is guaranteed. There is no overhead of network communication, so reliability is guaranteed. You can personalize the model to your deployment scenario. However, there are few complex use cases which may need talking to a central cloud. So we have a platform called AA100, and more are coming like AA250. So this is where most of our customers can have a on-prem cloud. So on their premise, they can have a private cloud network, and they can distribute certain workloads to private cloud and certain workloads to the edge AI, local AI device. So some of our customers are already adapting to this design and already deployed certain solutions in this particular format. And probably we are the key providers of AI hardware across the spectrum in the industry. Thanks, sir. I just want to stop here unless there are more questions.
Students, you have any questions for Ravi? You can unmute yourself and ask. So Ravi, while we are waiting for the students to ask any questions they have, I would like to introduce Professor Debashish Mukherjee, who is also joined us, and we are offering the course together. And he is a postdoc in the GPU domain. Debashish, you can just introduce yourself shortly. Okay, no problem. Yeah.
Yeah, good morning. I'm Devashish Mukherjee. I'm currently working as an assistant professor in RVU University. So this semester, I'm currently teaching co-faculty as for the course Accelerated Computing, which me and Molly sir, we both are teaching in this course. And thank you for organizing this guest talk. It will further strengthen our knowledge and as well as our student interest in this area. So thank you.
Thank you, Devashish. So Ravi, if there are no questions from us, maybe Venu can start with his presentation.
Yeah, sure.
Hope you can see my screen.
Yeah, Mr. Venu, we are able to see your screen.
So, my name is Venu. I'm from Qualcomm, Hyderabad. I have expertise in camera as well as currently my keen interest is collaborating camera systems plus AI to make imaging solutions. So that is my area of interest. Currently, I'm also partnering with universities to provide QIDK innovative kits for academics and developers to use this platform and develop their own solutions. So currently, the Qualcomm QIDK kit is a Qualcomm Innovator Development Kit. So it is mostly used for academics as well as for developers to develop their own solutions and deploy on any commercial platforms if needed. So as Ravi updated previously, right? So this is like a QIDK kit, which is similar to the mobile device. So the similar chip can also be currently this is like a chipset which is similar to Samsung GS25 Ultra. So it has a similar capability. So we have different variants of these chipsets, which can be the capability of a Samsung GS23, GS24, and GS25. It has the similar capability. So this is the form factor of the QIDK kit. So here we'll have the processor, and also we can integrate different sensors to this. We can integrate the sensors like gyro, accelerometer, magnetometer sensor, as well as we can integrate the camera sensor as well. And also we have different peripherals which can be used to enhance according to the requirements. So we also have a display which also can be integrated to this, which has a touch based display. So we have the OS which runs on this is like an Android OS. It has the latest Android, based on the variant of the chipset, it will have the latest Android running on it. So currently you can say that it can run a latest Android 15, so which is released last year. So it has the capability of running that Android OS on this particular platform. So this is the pre-installed software which has the Android OS, and it's a modular device hardware. So you can integrate whatever hardware you want on top of this. So along with this, we have we provide open source sample Android app solutions, which is part of the QIDK GitHub. We provide sample solutions so that you can use that and understand the solutions which are available, and scale those solutions according to the use case of the developer or any academic solutions. So this QIDK kit has been deployed in various universities across the world, not only India, in IITs as well as across the world universities as well.
Venu, if you are aware, we
yeah,
have two kits of QIDK here in RVU.
yes.
Thank you. Thank you for the. Yeah, please go ahead.
So we have some documentation as well as video tutorials. I can show this details in later slides. And once you have any solution which has been deployed on this, so it can deploy this solution on various platforms as Ravi updated, like you can deploy it on mobile, PC, XR, any other IoT platforms as well. But depends on the performance. There will be slight performance difference. Yeah. Is there any question?
There was some noise, I think. Somebody has unmuted by mistake. So please carry on.
So, as I said, like the QIDK has it has been there from a long time. These are the variants of the chipsets which are available. So currently, it's like we have 8 Gen 2, which is like JS23 chipset, which is like Samsung JS23 Ultra. It has a similar capability. And JS 8 Gen 3 has a capability similar to JS24. And we have 8 Elite. This is already available. It's not upcoming. So it is already available. So it is like has a similar capability of JS25 Ultra. So you'll at the university, you might have this QIDK kit, which has the similar capability, which can deploy any model which like Ravi update, it can has capability of running 1 to 10 plus billion parameter models. So we do offer different resources as part of the QIDK kit, so that it will be useful for the academics and the developers to understand the QIDK hardware platform as such, what is the capabilities of this, as well as what all the peripherals which are available as part of that. So here is an hardware unboxing video, which is just an YouTube video. We'll share this details later. So you can see what all peripherals which are available, and think of solutions which can be using these peripherals like camera, sensors, and based on that, you can deploy the model accordingly and also gather the required information in real time and train the mod. Once that model is trained, you can do the inference in the real-time data. So we provide, as Qualcomm Academia, we provide the coursework for this QIDK kit. So this has the details of the QIDK platform as well as related GitHub details. Along with the GitHub details, we provide some solutions related to object detection models as well as large language related models has been part of this. So we provide the details of those solutions, end-to-end solution which has been developed by Qualcomm. So that has been offered as part of this GitHub. Those details will be provided in this coursework as well as in tutorial. We'll provide the details of the once you have the model ready with you. There is a particular process you need to follow to deploy that solution on the Qualcomm platform. So we provide the details of the tools which Qualcomm provides to convert the model from open source like TensorFlow or PyTorch or ONX model onto the Qualcomm platform. So that related details has been updated in this video tutorials. We have, as I said previously, right, we have this demo sample Android apps as part of QIDK GitHub. So this we have as for students and developer to see how to develop an Android application. We provided steps from scratch. So from getting the ONX model, converting the model onto a Qualcomm platform, and how to use any Android application, and how to use this model, converted model, and call the required APIs and do the inferencing in real time. So these are a few examples which has been provided as part of QIDK GitHubs. Using these solutions, right, you can, according to your interest, you can use this as these are just sample applications which we provide, but you can develop your own models and deploy that. So or else you can use these models and scale these models further, like any solution like which you have in mind. So you can use these solutions as part of that. So to make the QIDK onboarding a little smoother, right? We have we developed a documentation and video tutorials. So this is the flow which you need to take right from understanding the resources which are provided to end develop an application. So this is the end-to-end flow. So here currently, as I mentioned previously, right? First, try to get familiar with the QIDK Git, QIDK like the device. So see this short video. It's like less than 10 minutes video. You can get a complete idea of the QIDK Git hardware, as well as once you go through the coursework and video tutorial and this open source application, right? You'll get a complete idea of what is a QIDK Kit, what are the possibilities with the QIDK Kit. Once you have that idea, right, then these are the other tools which can be used to make the open source model on deploy it on Qualcomm hardware. So this is the like the flow which you need to take in order for the smooth deployment. So as Ravi mentioned, right, there are around 200 plus models which are available in Qualcomm AI Hub. It can vary across domains like audio, computer vision, generative AI, multi-model. So there are a lot of models which are available within this AI Hub. So you can use this, deploy this model directly on QIDK, or else you can try to uh, take this solution and add certain features on top of it and develop an Android application. You can do various things with this particular models. So we do have a roadmap for QIDK with respect to upcoming Gen AI editions onto the QIDK. So as part of that, we are planning to add this as part of this and the coming year. So we have a plan of adding a chat app, which can use a Llama LLM model, which can be used for chatting with the Llama model and get the required answers for you. So next is like speech to image. So it's like you can use a whisper model, which can it can convert from a speech to text. So using that text, you can provide that text to the stable diffusion model, which can provide you an required image. So you can also do speech to speech. Either you can use a model like speech to text and text to speech, or else you can directly, if there is any particular model which can do speech to speech, you can use that model as well. We are planning to integrate this could be little later, like in 2026. So we have a plan to add a vision language model. So what we are trying to do is like we are trying to provide a basic sample capability of QIDK platform. So we encourage the students, professors, and the universities or any developers to use this sample, like for this is for understanding the what is the capability of QIDK platform, as well as you can deploy or scale these solutions and make some innovative solutions on top of this. So
Venu,
yeah.
I have one question. Go back, please. This Gen AI models that you are planning to offer, will it be possible to use it on the AI hub also? Will it be made available there?
There are generative solutions which are available already on AHub. You can, like the Llama model is already available there. So you can extract that model and deploy it on QDK as well.
Yeah, even QIDK we can access it remotely also. No, I think we ran one experiment in the last 2 semesters back in a JA course where we used the AI hub for running some of the models on the uh, mobiles that you have it on the cloud. So I think QADK is also available on the remote cloud also, right? In your lab setup.
Yeah, we do have. It's available. Yes.
Okay, sure. Thank you. So I think we can open it for any questions from the students. There are some students who have even done the projects uh, on QADK in last semester. So any of you, please, it's open. I think it's a golden opportunity for all of us to talk to Qualcomm directly. Please feel free to ask any questions that you have in mind regarding whatever he is presented or anything what you have in mind. No issues. Please go ahead. If you are not able to unmute, I can do it, but please let me know if you have any questions. Anyone? Since they don't have anything, I just wanted to ask you, based on, I think you are coming to different colleges for placement, even reaching out to some, young engineers. Just wanted to ask you, in case, any of us, not in case, and all the students here would love to be part of Qualcomm. So, what are the skills that you would be looking for? And what they should be strong in terms of technical skills. If you can just throw some light on that, that will be great for our students to aspire to join Qualcomm. If not now, maybe in the future.
So, if you are interested in AI domain right now, so if you can showcase any good uh, innovative solution with respect to AI, I think it will be very so based on those things, I think if you can, as part of this collaboration itself, if you can show that, I think if our managers and lead director are interested in once they see these solutions, right, innovative solutions, they can easily hire respective engineering folks. So it will be very easy. So there could be like an interview based on those things. So that kind of thing is very easy to get into this kind of. Yeah. So if can you build your resume based on those projects, uh, based on the AI projects, it will be very easy in my understanding.
Thank you, Venu. And there is one more question from one of the students here. How does Qualcomm plan to place Arduino acquisition with their AI journey? Are you?
I'm not the right person to answer those things.
Yeah, that's what.
But
Maybe I don't know. Sumant will have some idea
no, I think
about the Arduino acquisition.
we are not allowed to
Yeah.
Oh,
really
talk about it. Okay,
discuss.
okay.
Yeah. So
I
there are some
understand it.
mistakes.
Yeah,
You joined.
exactly. So,
So
yeah.
if
No
anything is
problem.
available, I think it's already mentioned in our Qualcomm uh, portal already related to the acquisition
Yeah, so
case.
there will be a
Yeah.
press release, maybe you can find it. So that will give the details which should have been, which we can communicate at this moment. Yeah, any more questions, probably we need to wait once it is public.
Sure, sure. I
It's open
understand
to
the confidentiality, Sumant, and no issues. So
Yeah.
again, I'm opening the forum for anyone to ask any questions. Please chat on the chat. You can write it or please ask. Anyone? Okay, I don't want to take their time. Thank you so much, Sumant and Venu, and Ravi has dropped off. He told me that he has another meeting to catch up on. So it was wonderful to talk, listen to you about the QIDK solution and in general what all the AI related solutions that you have in Qualcomm. And it's a great opportunity for all our students to listen to you. Sumant and Venu, if you can share the slides that you have used, PDF version, if it is okay with you, I would be able to put it on my course page. You can do that later part of time. Okay. So if you don't, no other students have any questions, I think we can wrap it up. And thank you so much again for taking time off in your busy schedule and talking to our students. It's really wonderful. Thank you so much. Bye bye.
Yeah. Bye. Thanks. Thanks, everyone.
Thank you. Bye.
Yeah. Thank you, Professor. Thanks, everyone. Bye.
Thank you.
Recording stopped.